Everyone, welcome back. This video we're going to talk about reinforcement for slab. Now we did calculation for foundation, reinforcement in foundation and in beam. Now slab is a combination between two of them. What does that mean? The way that we calculate reinforcement for foundation XY direction, we have to do the same thing for slab. The slab is two-dimensional. So you have reinforcement in two directions. Well, you may have one layer, you may have two layers. You may have two layers. Now, the two layers can be similar to the one as foundation, or the two layer can be similar to beam as a bent bars. So you have a combination between slab and beams reinforcement. Two dimension. You may have two layers the same way as the foundation we did it, or you can have bent up bars inside it. So how do we know this one, which one we have it? We'll go to the plan and read from it. Now for the plan for slab, we're gonna go to the place when we have beam and slab. Now you don't have the reinforcement here, they didn't provide it here. Some they provide it here the same way as the foundation. They'll provide the detailings here some, but mainly we'll look at it on the drawings here. We look at it on the drawings here. So which one are the reinforcement? Those are the reinforcement, we have it here. As you can see, those are the reinforcement, we have it here. Again, the same way for slab, they will be provided like this, as if you're looking at the slab in this manner. Please remember. So what does that mean? This is the top, basically this is the bottom bar. Choose different color. This is the bottom bar. This is bent up bar, we have it here from the top, comes down and goes up. And this is additional at the top. This is at the top, we have it here. This is how you read reinforcement for the slab. They will provide it on the plan, but you think of it as well. This is the slab thickness. Remember please, this is the slab thickness. This is the slab. You'll see it as this way. Well, let's look another place. Look, everywhere that you see that they will provide in this manner. So the X direction, the Y direction, yes. Each slab, they have two direction as well. Like for example, this slab, I have it here. I can take the reinforcement out if it is too crowded for you to see, but I'll highlight it for you. This is the other direction. Which the other direction means that you're looking at the slab in this way. So what we have the bottom of it. This is the bottom bar. And this is the bent up bar that we have it. So you have bottom and the bent up bar, we have it there. Well, in order to calculate it, we have to provide what? X, Y direction. Now, let me see if I can make sure I can make this one a bit see that if it can be crowded for you, try to make it a bit easy. I'm taking only the, let's see if I can take out those. Sorry. Those are what I need them. So if I can just take them to see Okay, we can make it here. Okay. Now I try to bring out the reinforcement for this slab, for the D101. I think it's with D102 or it's D101. So I'm writing it here, and just to explain for you. D101. This is for you if it is too crowded there. I just took it out in order to explain the things there clearly. I think one of the information didn't come, which is this one here. We have it. Now, we have two direction, as we know from the foundation. We have two direction here. So again, the direction will decide it the same way that we did it in the foundation. The x direction, which one will be the one that perpendicular to the x direction? Those will be for the x direction, and those will be for the y direction. Now we write x direction, top, bottom, whatever we have it bent up that we know. So we start with x direction. I can bring the same thing here for the foundation I did it. For example, I'll start with the y direction, let's say. Y direction, what do we have? Now, the y direction I have bottom and bent up. This is for the y direction. We have bottom, I have bent, I have top as well. This is for the top. So I have top, bottom, and I have also bent up. So y direction, we have bent up as well. Bent bar. Now, sorry, this is the y direction we said, this is the y direction, x direction, and we said those are what we do for the y direction. So we write it down the way that they are. Y direction top, you see which one is it? We have 8, phi 8, but we have a problem there. We'll come back to it now. It's something we haven't provided, so we'll leave this one because there's supposed to be a number here. How many of this one you have it? The length you have it, the diameter you have it, but the number they don't give it to us. It's not provided to us. Well, we'll do the others. We'll come back to that one to teach you this. You know how to find it, but let's say to teach you. Well, we'll go for the bottom one. The bottom bar, we have it 11 of them, phi 8, and the length 330. I'll just read them from there. That's it. The bottom bar, I have phi 8 millimeter, 11 of them I have it. I don't care about the spacing. 11 of them. The length of it 3.3, and I only have one. Let's see, I'm just calculating for this slab. For the bent up bar, I still have 8 millimeter, as you can see it from here. This is 8 millimeter, 11 number of it, the length of it 405. So we'll write it here again. 11, it's 4.05, and we have one for that one. However, for the top, we have 8 millimeter. I know the length of it is 1.5 meter. But how many of them I have it here? How many of this one I have it here? It's not provided in the, I think it's not even provided there, if I'm not wrong. Yeah, it's missing there as well. It's missing here. Now, how do we find these numbers? How many of this one we have it? Now, I need you first to understand this one here. Those top bar come from where? Come somewhere in between. This is where we place them, because when the bent bar comes, it already is the top, so you'll put between the bent bars. Look, the bent bar already coming there, they're already there, the bent bars. So when you do, you'll put one in between the bent bars. This is the top one we have it there. So if you just look at the numbers we have it here, how many bent bar I have it here, for example, just let's calculate them. You know exactly what do I mean. one bend bar. Change this one smaller. We have 2, 3, 4, 5, 6, 7, 8, 9, 10 bend bar I have it. If I have 10 bend bar, how many in between them I have it? I'll have 8, because one there, one here, so I have 8 between them. I can simply calculate in this manner, because it will go between the bend bar, yes? So if I go back to the plan that I have it here, between the plan I have it here, now we know that we have 11 bend bar, yes? I have 11 bend bar. What does that mean? I have another bend bar here, like this. So if I continue, I'll do it like this. There will be another bend bar here. I have 11 bend bars, goes like this. This is, and those additional comes in between them. For example, it comes here, the other one comes here, the other one goes like this. So you have 11 of this one. Basically, I will have 9 of these bend bars, those additional. So I have 11 of the bend bar, I have it, 11 of them. As I showed to you here, we had something you will put in between them, so you can get it to be 9. We have it for the top bars there, 9. Or what will you do? You will have calculated in detail, starting from here till here. This is going to take too much time. This is the easiest way to do it. You start from here till here. This is the slab we have it, yes? You will first put these bend bars, and then in between them, how many bend bars you have it, starting, for example, if you put 1 here, or maybe you will start the bend bar from where? You may start bend bar from here. The bend bar may start from here. So you will see how many bend bars you have it there, which is, you already know, 11 bend bars. If you don't know this one, then you can calculate this one comes in between them, which will be 9 of them. So this is the easiest way to think of it, like this. It comes in between them. You have, for example, 11 of them. So take 1 there, 1 there. In between them will be 10, by the way. Sorry, yes. So in that case, it will be 10. We have it. If I put between them 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, because we have 11 there, 1 from there, 9. So the same thing we have it here. Luckily, it was 11 years. The same thing, 11 we have it here, because we have 11 bend bars. Oh, we have 10 bend bars here. 10 bend bars, 9 of them. So in our case, we have 11, we'll have 10 of that one. So in our case here, since we have 11, that will be 10 in that case. That will be 10 additional in between them. So we can write this one as a number to be 10 of this additional 1. Now, it might not come exactly 10, because the spacing is a bit smaller than this one. That's something else. Let's say 9, 10, but it will be provided by me. I'm not going to allow you to do this calculation, remember? But it's good to know how to calculate this one, which later you'll get them from the design courses. So this is Y direction. You will repeat the same thing for the X direction. But in the X direction, what do I have? I don't have top, I just have bottom and bend tab. That's it. You will just do the same thing, top and bottom and bend tab. We don't have top, so you'll just do this one. We do it for X direction. Now for the X direction, there's still 8. We're looking for which one? We're looking for this one. If this is X direction, remember the perpendicular one. The perpendicular one. So for the bottom, 9 of them I have it, and the length 435. For the bend tab, I still have 958 millimeter. The length of it 595. I'll just change the values here. We have it. For the bottom will be 4.35. The number became 9. For the bend tab is 9. The length of it 5.95. That's it. This is how you calculate reinforcement for slab. Doesn't matter, you may have bend tab, you may have just top and bottom. You'll do the same way that for the combination between foundation and the beams that we did it. Thanks for